Very good afternoon to all of you. Welcome to the series of mathematics required for machine learning. This is the sixth video. We speak about data representation in a real world environment. So, in a real world environment, if you look into it, the data is in the form of tabular form. So, the tabular form can be represented in the form of a matrix. Each row we are considering as a data point, and each column we are considering as a feature or attribute in terms of machine learning. The tabular representation is very useful and efficient for storage and manipulation of data. Data representation related to machine learning using matrix algebra in linear algebra we are going to discuss today. Here the example I am showing how a data set look like. So how do we storage the data sets in the cloud? These are the things we are going to discuss today. And we'll take an example. The house prices with three features we are considering. What are they? Area in square feet, number of bedrooms, number of bathrooms. So based on this data, we would like to predict the price of the house. We'll take a middle level town where the prices of the houses were mentioned here in terms of lakhs. If the area is having 2000 square SFT and 3 bedroom, number of bathrooms are 2, then 39 lakhs. And if it is a 1500 square feet area and number of bedrooms are 3, number of bathrooms are 2, so the price is 32 lakhs. If 2200 square SFT, the house is, number of bedrooms is 3, number of bathrooms is 3, then 46 lakhs. Like so, we are considering the prices of various houses. This is how a real estate person stores the data for the prices of the houses. And one more parameter also we can consider, it is a location, because location also plays major role in predicting the price. But here we restricted to three attributes or three features. What are they? Area, number of bedrooms, and number of bathrooms. Based on that, we are going to predict the price also. Already we discussed in the earlier video that linear regression. So here we are going to consider multilinear regression and to predict the price. But I am not going into the details of multilinear regression right now, just how the data set is going to be represented into the matrix form. That's where we are interested in today's discussion. And here, if you see, each row is a different house. Each column, different attribute. You can see each row is a different house. And there are 6 houses we have represented. And each column is an attribute we are considering. That is called feature, F-E-A-T-U-R-E. And here, represent a data set as a matrix for ML. How do we represent this data set in the form of a matrix? And now we will denote that input data as X and denote the target variable as Y. In the given data set, if you look at, these three are the input variables or the input attributes, what we can consider. And this is the target variable, what we have to predict. So this is how we are going to consider the data sets. In realistic environment, we have lakhs of records. So there we have to divide into training and testing. And we have to train the data set. And after that, we are going to predict the prices. So once we do this way, then we can take the unseen data. And then we are going to be able to predict the price of the new house. So based on the performance, of the algorithm or the method we use. So target is the price, which is the attribute we need to find for a new house. So if you look at the data representation in the matrix form, one side we can call it as a feature matrix, another side we can call it as a target matrix. In the feature matrix, we are considering three attributes as I told you earlier: area, number of bedrooms, and number of bathrooms. So whole that data set, if you look into this column, and this column values we have represented here. You can see this. So six data points are there that we have considered, and three attributes are there we have considered as area, number of bedrooms, and number of bathrooms. Now we are looking into the target matrix, where the price we are going to have for these data points. So for a new house, then we need to predict the price of the house. This is called target matrix. This is called feature matrix. So now what we are going to do is, this is how a matrix representation comes into the picture. Now we are going to look at, we can use the matrix algebra to perform various operations related to machine learning. One is linear regression. As I told that the multilinear regression here is important. So we can use matrix multiplication and inversion to find the coefficients of the regression model. Once we find the coefficients of the regression model, we can predict the house based on these features. And feature scaling. So here, if they are of different sizes, that means the ranges of each attributes are different. Then what we need to do is, we have to normalize them, or standardization to the columns of the feature matrix X. Then only we can able to predict the house price in a efficient manner. So the matrix operations, if you look at, they are transposition, multiplication, inversion. Like this, many operations of matrix can be implemented for various algorithms, ML algorithms. Matrix algebra allows you to manipulate and process this data efficiently, making it suitable for use in ML models and algorithms. The realistic data sets are larger and complex. Here I showed only 6 rows and 4 attributes. In that, 3 attributes are input matrix I am considering, and the fourth one I am considering as a target matrix. But in the realistic data sets, if you look at, they have 50 to 80 attributes also there. And the number of data points, that is number of records, if you look into it, or rows, if you look into it, 1 lakh, 10 lakhs, or 1 crore also there. So more complex in nature. So sometimes you don't have the only numerical attributes. You may have categorical attributes also. There we need to convert into the numerical. Then we need to go ahead about that. And linear algebra plays a crucial role in handling and analyzing the realistic data sets. So in summary, I can say realistic data sets are represented in matrix form, and we perform the matrix operations like linear regression, feature scaling, matrix multiplications, inversions, etc. for effective manipulation of these matrices. So which are inter representing a data set. With this, I conclude this session, and thank you all. And please do subscribe so that you can get the new videos informations, and any doubts or any clarifications, please share in the link below. Thank you, one and all.